So hi, my name is Matt Kuperholz. The way I spell my name should be a dead giveaway that I'm a massive computer nerd. I was born in 1972, which was the same year the first microchip was released from Intel, and I've had a long-lasting love affair with computers since the late 70s, which meant I was very much in the right place and right time to be a data scientist. I am the firm's chief data scientist. I'm very proud of that. So I give out lots of business cards because it says Chief Data Scientist on it. I'm also a partner in the analytics business, and once upon a time I was an actuary, which is what you did when you were good at maths and you wanted to go into business. But I also did computer science, and everything I was doing in my actuarial career, I was taking in a computer direction. And in the mid to late 90s, I said, you know what? There's got to be a way to bring my passion, which is computers, together with being decent at maths, and that turned out to be the very early days of data science. We just didn't know it at the time. So I've been fortunate to be sort of at the forefront of data science, which to me is about getting value from data. And it's a really interesting concept, this idea of data as an asset. In fact, when I first left the actuarial firm for an artificial intelligence startup in the late 90s, I was talking to people about the fact that their business problem could possibly be solved with data. And it was interesting, you're having this conversation with, you know, really intelligent business people, and they're saying, really? We could possibly use data to solve our business problem? It just seems so obvious now. And one of my favourite sayings is, in God we trust, all others must bring data. That's from W. Edwards Demings, who almost single-handedly reinvigorated Japan's manufacturing industry using statistical production methods after World War II. It's almost now that we're being negligent if we're not bringing data to bear on a problem. A fantastic guy whose name was Gordon Moore, and in the mid-60s he invented the semiconductor, a way to put transistors onto silicon. And with 4 data points only, so 4 years in a row, he said, wow, the number of chips, number of transistors on this chip is doubling every year. And it was coined as Moore's law. It was later adjusted to 18 months. But he actually refuted his own law twice. And why did he do that? He did that because the idea of having something grow exponentially is really foreign and unnatural to the human mind. Exponential growth, doubling, is such that we don't recognise it for so long, and then it just shoots upwards at this incredibly spooky rate, and it feels like nothing can really continue exponential growth. But in fact, since 1965, the number of processors on a chip has doubled every 18 months, unbelievably. And what the Singularity University talks about is this idea of an exponential technology. And again, you know, just reflecting on exponential growth, one way to picture how hard it is to get our head around it is if there's a pond with lilies in it and there's no lilies on day 1, and then there's 1 lily, and then there's 2 lilies, and there's 4 lilies, and it's doubling every day, and by day 30 the pond is full of lilies. When's the pond half full? The pond is half full on day 29. And on day 25 it doesn't look like it'll ever be full. So such is the nature of exponential growth. And what we learn from futurists like Ray Kurzweil and Singularity University is it's actually not just the number of processors on a chip that's doubling exponentially. It's the performance per dollar of a huge number of technologies. The number of sensors on a digital camera, gigabytes, terabytes of storage, communication speed, sensors. So if you've got data processing, the processing power of chips with specific types of maths, artificial intelligence, genetics, robotics, all of these things are exponential technologies. So too are things like solar and other forms of energy where the inputs aren't limited. So if you've got all these exponential technologies and they're actually all colliding, it means very quickly we're going to find ourselves in a massively exciting new world. And sometimes, you know, especially from vendors and a lot of the hype around things like artificial intelligence, and it's a speciality of mine, but you really have to be able to define intelligence before you can actually understand what artificial intelligence is. It's not very easy to do. And we're often anthropomorphic. We think of computers to pretending to be like humans. It's quite likely that true AI is going to be anything but that. Also big data, that's just the exponential growth of data, the exponential growth of the volume of data, the velocity of data, the variety of data, the value we can get out of it. It's actually not something new, it's just this curve in action. Same too with robotic process automation, because we are able to use algorithms that have really been around since the 60s. We just now have more data to put in them and more processing power to stack them. The fantastic computer vision that's now available is really something called a deep learning network. The same as the best chess computer in the world learned chess in 4 hours. And there's in fact a great Netflix documentary called AlphaGo on just this. These algorithms aren't new. They are literally unchanged since the 60s. We just have exponential amounts of data and exponential amounts of computing power to apply to them. Robotic process automation isn't new. It's computer scripts. It's just powered now by faster and more intelligent algorithms and more data. So too, the Internet of Things, the massively connected amount of devices at a very low cost, which is going to change our whole world, isn't necessarily new. It's just sensor performance per dollar and communication performance per dollar, and processing power per dollar means it's realistic that everything will one day be connected like the lid of this bottle of water. And the last mega trend, which I think actually is genuinely brand new because it's a new type of using mathematics to put a layer of trust in a distributed network that's never been used before. And I'm bullish on blockchain, not everyone is. I spent most of last year using blockchain together with these other 4 technologies to help a consortium including Alibaba, Australia Post, New Zealand Post, Fonterra and Blackmores start to make a dint on counterfeit in China by actually tracking the provenance of goods through a supply chain. Nevertheless, with all these new and exciting things in exponential technologies, we also need to beware or heed Amara's law. Roy Amara was a futurist, died in 2007, and he said, we tend to overestimate the near-term effect of a technology and underestimate the long-term effect. Or in plain English, there's a hype cycle where everyone's talking about it, making you feel like you're left out or you're going too slow or your company is the last one to get it, followed by this trough of disillusionment. And only then do we attain the full value that these technologies hold as promise. And interestingly for AI, the true AI winter was actually in the late 70s when the government funding dried up, when it turned out they couldn't solve all problems for all people. And coming back to the standard analytics process, which I want to describe briefly, most importantly, start with a business problem. Don't start with an analytics problem. Start with a problem that someone is feeling the pinch on and they want an answer to. And when you start with the problem, have in mind what you're going to do with the solution. So I often say, someone might say, I've got a problem with customers churning. I said, all right, build me a predictive model. I will give you a magic wand that will tell you exactly who's going to churn and when. Take as given that that black box exists. Now what? There's process, there's cultural change, there might be legal constraints, there might be marketing constraints, there might be anti-competition. Take as given that the analytic engine can be built, and then think of all the other things you've got to do around it to get the value from it. So when you start with your business problem, have a view to the last step, which is what am I going to do with it? The second step is understand the assets you have both inside the organisation and externally. And external assets might include social. Social analytics is something I invented over 10 years ago I could use Facebook to predict who was going to claim on a car insurance policy. That's the place where in social media your customers and your employees are actually giving away their emotional state and people make decisions based on emotion. So it's a great data asset. But inside the organisation, there are assets all over the place, rarely perfectly connected. Understand what those assets are. Preparing the data. Whilst the fourth step, modelling, we're using AI, we're using deep learning, we're using optimisation techniques. This seems really cool. This is where the art and the science of data mining really adds value. Fantastically prepared data using a less powerful technique delivers more value than poorly prepared data with a leading edge technique. And this is also 70% of your effort on any analytical project, whether it's a sprint or a couple of years. So having a common language for how we take data on a journey from its source systems through to what it needs to be to shed light on the business and making that reusable You know, you'll have transactional data inside most organisations. I guarantee you there are tens of analysts picking up exactly that same raw data, doing more or less the same thing with it, incredibly inefficient, incredibly risky. They're all doing it their way, and then they're modelling it to get some answer to a business problem. What if the organisation culture was that that was done once, and there was a common data mart for using prepared data? Then you model it. The technique depends on the problem. Is it classification? Is it prediction? Is it optimisation? Is it chop, slice and dice reporting? You evaluate your models against the business need, and then you deploy them. You've got to do something with it. Too much analytics turns into shelfware, sits on the shelf gathering dust. This is mostly for AI. There are going to be many techniques that you're just not going to understand, especially in the future as these exponential techs grow. And as Matthew Bishop said, the pace of change is never going to be as slow as it is today. But what will stay the same is an analytics process, whether you think about it in 6 steps or 4 steps or 8 steps. Ensure it starts with a business challenge and finishes with deployment. This has released value to almost every industry under the sun. I've done everything from growing tuna fish to picking up garbage to making ammonia, which is fantastic. I just love the variety of the challenges. And answered any number of questions from getting the most out of your marketing dollar to keeping your customers, your students or your employees. The common bit is the heavy lifting of the data should be reusable. It's got to start with the business, it's got to be deployable, and it's got to have support from the top. But they're not going to give you support forever, which is why I break it down into incremental delivery of value instead of considering it an IT initiative that will last for 12 or 18 months.